Hi, Dr. Prowl. My name is NicholasPenrose, and I'm a third-year mechanical engineering student, currently in your Mech 300 class. And for my Mech 300 project, I decided to create a ski waxing clamp. I chose this project for a couple of reasons, mainly because this winter I was uh, waxing my skis by balancing the skis in between a couple chairs or just on the floor, which is not ideal because the skis move around a lot and creates a big mess on the floor that's not the easiest to clean up. Um, by having a clamp that I can use to clamp the skis to the table, it'll make it a lot easier to lay down a trash bag and pick up the shavings of wax, as well as keep the skis in place and get a much cleaner wax each time. Traditional ski waxing clamps can go for over $100, and by 3D printing them, I'll be able to save a lot of that money. And yeah, so the purpose of the purpose of the project was to make waxing skis a much easier process. In order for that to happen, the ski waxing clamp needed to be able to withstand the amount of force required in waxing skis, which I determined by laying down a scale and putting as much force as I would put into scraping skis onto the scale, and I found out that 30 pounds of force is about how much I needed to withstand. Using that information, I chose to, using that information and consulting my roommate who has a little bit of experience 3D printing, I decided to 3D print my ski waxing clamp out of PETG, as this material has a high enough strength and according to my roommate, was easier to print with, which, as far as I could tell, seems to be true. Um, the ski waxing, this is connected to mechanical engineering because it solves a problem that I had, and I believe that the main purpose of mechanical engineers is to solve daily problems and make life easier. This will make life easier for me, at least each winter while I'm waxing my skis. The ski waxing clamp is made out of 5 parts or five separate printed parts, but in Creo I ended up making it 4 parts. There's 2 screws. There's the base, which is made. I needed to print out of 2 parts in order to get the threads correct on the bottom, and have a size part that will fit on the 3D printers, as well as the slider, which moves across the top. In order to create these parts, I used SolidWorks, and I used this project as an opportunity to familiarize myself with SolidWorks, as many of the companies in industry tend to use SolidWorks instead of Creo. Um, uh, so from that, I took inspiration from the online commercially sold versions of ski waxing clamps, and reduced it to its base functionality, which is 2 C clamps, one to clamp the table and another to clamp the ski. I had no idea what kind of threads would work with 3D printing, so I went on to Thingiverse and downloaded a SolidWorks file of someone who had made and printed a screw. I then took that file and screw and scaled it down to 1/5 its original size. I then lengthened it to be the length that I wanted and made a copy to make the horizontal screw and adjusted which part of the screw was threaded. I decided to leave the original head of the screws as seen on the original component that I downloaded from Thingiverse, as a reminder to myself not to over torque it because I'm not sure what kind of force these threads can handle. Um, and so by leaving it as a smaller head, it won't give me a lever to pull on to be able to rip the part apart. As an assembly, the ski waxing clamp looks like this, which I'm sure you have in front of you. This is a picture of the ski in the clamp, and it did a very good job. The first iteration of this, I had forgotten to take into account the height of the bindings of the ski, and so when I had it all printed and everything was great, and then when I put the ski on it, the ski wasn't even able to be in the clamp because the bindings were above the top of the clamp, just having it upside down on the table. As you can see, Toco and Swix have a similar product that are over $100. They also have 2 supporting clamps. I decided not to print those, mainly because of time and also because typically I'll just use a cardboard box to underneath each one to support it. It provides a lot more area for the force to be distributed and tends to do just as fine as printing another clamp. Mistakes I made. It took some time to figure out the proper clearance and pitch angle of the threads in order to get them to print properly. Um, and I wanted to use as many different functions of the 3D printer as I could. So um, one of the components is very curved on the base of the clamp, the bottom part of the base. So I used support material on that, and I was able to use the accuracy of the 3D printers in order to print the threads. Um, as I said earlier, one of the mistakes I made was forgetting to take into account the height of the bindings of the ski and how that would affect the necessary design of the ski clamp. Um, I Through this project, I became familiar with and comfortable with using the 3D printers in the I2P lab. Um, Freshman year, I had come into the lab and done the training and printed just like a little ram's head, but I was still intimidated by the lab itself and the capabilities and being able to use the 3D printers. Through this project, it forced me to learn how to use Cura and how to 3D print properly, and I'm no longer intimidated by walking in and using the 3D printers on my own, which has been very nice, and I intend to use that this lab next year for various projects. Um, yeah, so I'd like to thank you for the opportunity to learn about 3D printing and the various positives and negatives and ways of doing it and the future of the field, which I think is rapidly expanding and eventually will become just like a regular printer where everyone has one. So thank you very much for the opportunity, and I hope you like my project.